Ladies and gentlemen, welcome back here on the innovation stage. We are coming to speech number 2 for today, and we keep on going with new technologies, new insights from the industry, and we have an exciting topic to come now. Our next presentation comes from Schaeffler Technologies, one of the market leader in our industry, and the company is known for worldwide for its bearing solutions. Today's talk is about rotary table bearings and how they open up new applications in the field of machine tools. And I'm super glad to introduce Martin Hertel, who is expert bearing sector development at Schaeffler. Martin, stage is yours.
Hello, nice to meet you. So may I introduce myself a little bit? So I'm Martin Hertel, working for Schaeffler Technologies, having 25 years of experience in building up rotary tables. And now I can make business development in Schaeffler Technologies, looking for the tool axis. Developing some new bearings, and so probably you're very familiar with a 3-axis bearing, 3-roller bearings called YRT. And this old lady gets some new trouble, I would say, because we get some new market requests, and I just want to give an overview what we did the last 2-3 years to develop this old lady in a new style, what we do. First of all, I want to give you some overview about the big picture, how we see the market at the moment, what is going on from our side. Then we will go to some special needs, like we see a big trend to the automatization solutions. And then we have increased our portfolio in some sizes for the top speed bearings. And there we see a big market move going on in this direction. Last but not least, I try to keep my 30 minutes of time. Last but not least, we have a complete new bearing, a new concept, which is patented by Schaeffler, developed by myself. And so I'm really proud to present that to you. So the big picture at the moment, how we see the market is, we have, I would say, 4 big fields where we are playing on. So the first one is we think we are at the moment in the golden age of automatization. All over the world we see there is a big trend that we see that machine tool business need to be automated in front of the machine, that we have a league of high educated people who are working in front of the machine. So therefore we make exactly a bearing line which fits perfectly for this need. The second one is we see a big challenging in multi-process machines. So we think that the whole market of the machine market will go a little bit less, but the complexity inside of this market will grow. So therefore we see that there are multi-process machines like mill turning machine or hard turning and grinding machine, put it in one machine together, and this is something new what our bearing need to do. So these are special requests for the bearing, and therefore we have just put it out at a big efforts to improve the bearings in this way. The third one is, you know it, we are a little bit in a crazy world at the moment. We are in trouble. So there is in Germany a big effort, I would say, to bring money into the business we call defense this time. So we call it heavy cutting materials. So we're talking about titanium, about steels, which are very hard to cut. And this is something as well which is challenging our bearing. Sometimes we have very small movement, so there we need hybrid bearings or something like that. And so there we have as well a big effort, or we take a big effort to improve the bearings in this way. Last but not least, at the end, we have to look a little bit as well for the carbon footprint. So there are some solutions what we now want to give to the market. So in our view of the market, the last 2 years, 3 years, 4 years, we run to the direct drive situation. For sure, Schaeffler is doing that in Suhl with some special motors. But on the opposite side, we need as well, we have a standard driven rotary tables and axes. What is the big benefit out of that? Here we see that we can save a lot of time during assembly, and this is something where I think we can save money overall when we assemble a part, things like that, make machine easy, make life easy, and as well to have a little bit a new business case in mind for all machine tool builders, what we are talking now to you. I would like to give you a small portfolio overview that you have an idea what I'm talking about. So the YRT bearing it's a 3-roller bearing, and the way the rollers are located is like a Y. RT stands for rotary table. So this is a typical rotary table bearing, and this is a roller bearing. Then you see the ZKLF bearing, and if you are familiar with German, it's quite easy to understand, because ZKLF means zweirolliges Kugellager doppelt anflanschbar in English, 2-ball bearing where you can flange from both sides. So here we have the speed division. YRTS stands for speed. Yeah. ZKLF I already explained. Then we have our standard, our precision, and you see already something new. So we have the YRTC bearing, and then we have the YRTC-G. That's quite simple. Yeah, for the English guys, it's YRTC with a gear. So that's G stands for gear. In German, it's the same. It's Getriebe. So this is brand new, and we show that on our booth. And in the middle, we see the automation solution. So it's YRT-A for automatization. And if you would like, we can make an additional gear as well. And then it's a YRT-AG bearing. Last but not least, we have as well the option to make an integration of a measuring system. So at the moment, this is very, very helpful for the customer due to the fact because you have only one part which you have to assemble, which you have to align. That makes life much easier in design, gives you design freedom. The center hole is free, and you have the measuring system on the right level of the bearing. So there is no X deviation. So this is a perfect result, or we find perfect results for this integrated measuring system. One big benefit I want to point out, you see here the small reading head, it's called MHA, so it's measuring head absolute, and this one has a form contact, so that's quite easy to install. Think about in the laboratory, in the clean area, it's quite easy to assemble and disassemble an encoder. No chips, no oil, no topic, no trouble. But in the machine, it's quite necessary that you have an easy access to this kind of encoder. The scale is a steel scale. Here we have a cooperation with the AMO company, Heidenheim company AMO. So it's an inductive system. And the reading head is quite easy to install. Even I can do it, and I'm an engineer, so I'm not a technical guy, so I'm an engineer, but I can do that in 1 minute. Yeah, so you have to disassemble 2 screws, and you bring by form contact the reading head inside, and the measuring gap is already perfectly aligned. Like you see, we always have the center is free, there is a design freedom. Last but not least, we have this as well in the speed version. So it is YRTS MA. MA stands for measuring absolute or measuring in incremental. Why we have as well the ZKLF as a measuring incremental. You will say, Martin, we need an absolute scale. But this bearing is this fast that the encoder, that the electronic of the encoder will not achieve the same goals like the bearing can do. So we can make an absolute system, but then we reduce the top speed of the bearing, we reduce the maximum performance. With the incremental system, there is no worries. We can go to the full speed of the bearing, and we have a 1 volt peak-to-peak sinus closing the signal. So this is the overview. Here we are. So let's jump a little bit in the big area where we are now. It's a little bit out of our DNA because at the past, Schaeffler was always trying to do the very best. So nowadays we see there is this part of automatization. So there are pellet changers, there are feeding stations, there are everything in front of the machine. And this is a very price-sensitive market. And therefore, we just developed a bearing where we see that we should hit the needs of the market, yeah. And we see from some customers in Germany, yeah, so you know them very well, the big ones. They said to me, Martin, nowadays 80% of all our machines have the option of automatization in front of it. So there is a big market, and we want to be part of this big market to give you the right solution, technically wise and financial wise. So what I'm trying to tell you, what I'm speaking about is like this kind of feeding towers, the pelletization towers. You can see as well on our booth. We already have 2 big customers in Germany where we're successful with that. And the bearing, what I'm talking about, is now here on the foot inside of keeping the tilting. Think about, request from one of the big customers was, I have a workpiece 2 tons in 2 meter high and 2 meter of the arm length. So imagine what kind of tilting moment we have to resistance about the tilting for this bearing. For sure, we can have a cross roller bearing, but the cross roller against our new solution is approximately 30% less of stiffness. So what is the benefit? The benefit is that we can reduce the footprint by the same stiffness, or if we can keep the footprint, we keep the same, we have 3 times more of stiffness inside. Let's go a little bit in the details, because for sure the technical things are important for us as a technician guys, but you know, money makes the world go round, so we have to think about as well in the price. So if we compare, for example, the wire T bearing, which we have at the moment, this is our standard bearing. This is our, how to say, our flagship, what we are selling quite often. So, but you see here, all surfaces are super grinded, are super finished. So the idea was to say, okay, what is needed? How can we change? How can we save money? Yeah. So we go there and we make a completely new concept for DNA, for our Schaeffler DNA, and we go back from grinding to hard turning. We have a special idea of turning that, so that the heat treatment in the surface is less, so that the crystal structure is not a big influence on that, due to the heat treatment. So what did we do? So you see here already. Do I have a laser pointer? No. So I try to explain it. So on the upper part, you see there is in this area, so up there in this area, we just make an undercut, that we have only some surfaces which are machined in a proper way. The same inside here in the middle. Sorry, you cannot see it perfectly on the screen, but if you come to the booth, you will see it perfectly. So we keep some surfaces like in black, and we don't grind it because it's not needed for us, saving the money for the customer. The same, for example, for the screws. Here you see every screw head is milled out. So this is time on the machine. And in the new solution, we just did it like with an undercut. So it's a very, I would say, so the working title of the bearing was to make the bearing good enough for the market, and one of the big topics is the price. So we can reduce here the costs, approximately 35% of the costs are put it out, and this we can give to the customer and to have a quite nice bearing and quite nice product where we save a lot of money. The benefits we have in the wire T bearing is always the same. So the idea is to have this wraparound, like you see with these two actual rollers, and this gives a very, very high stiffness. The center is free, so you can come with cables and hoses for automatization very easily. Additional, I said already, there is as well an option to get it together with a gear. Then this part, we call it the washer. So this is the inner ring, the outer ring, and the washer. We take the washer away and we make an integrated gear already inside of this bearing. What did we do as well? So we have had a leak in our portfolio regarding the wire TS bearing. So wire TS stands for speed. So I would say, I'm honest, when I was 20 years younger, we just got the first wire TS bearings from Schaeffler side. I was working for a company, Rückle. And I was selling the new machine to Reiden, our X18 machine, and I just sell it with a new bearing of wire TS 580. Now, 20 years later, Schaeffler has it, because I was going to Schaeffler and I said, I need that bearing because it was pain in the ass that I don't have it. I've had it in the past. So I give my efforts there to develop this bearing, and now I'm very proud of that. We have now the wire TS in the past from 200 to 460, and now we increase our portfolio 580 to 650. We look a little bit different to this bearing now, a little bit from my point of view as a rotary table, rotary table builder. So I said, okay, we need to increase the top speed, yeah, but the top speed must fit to the table blade, and therefore I was taking a lot of efforts to increase the performance of the bearing. How did I do that? I do that by controlling the temperature. You see here on number 4, it's a speed. So this was 300 RPM, continuous running. Then in 2 and 3, this is the temperature of the inner ring. At 2 and 3, it's the temperature of the outer ring. For me, it was very important to understand that when we assemble the bearing, we heat up the outer ring. And therefore, we are going over the preload of the radial runway. So nowadays, we bring the outer ring, and then it cool down, and we have the preload. What happens if a bearing gets a heat escalation? Then the rollers start to slide. And therefore, I take a big effort that I can keep the temperature difference between the outer ring and the inner ring on 2 Kelvin. And this gives me always, I was sure the rollers were forced to turn. They're not sliding, they are forced to turn. And therefore, we get this high speed of a YRTS YRTS 650 on a continuous speed of 300. So imagine this is a table blade, 1,500, 300 RPM, continuous running. I think this can solve a lot of problems from the machine tool builders nowadays. Last but not least, we have this kind of topics. So we have a lot of requests from the defense industry, a lot of requests for hard cutting materials and things like that. And therefore, we just try to fulfill the needs of the market with some special bearings, with some hybrid bearings. Yeah, for example, if you think, if you have a ball screw which is running always in a very, very small distance, like oscillating, yeah, we face a problem with the grease. Yeah. For you as a machine tool builder, you just see the damaged machine. For us, we see the damaged bearing and we ask ourselves, what did they do? So think about grease inside of a bearing helps to prevent the contact, steel-steel contact. So therefore, the grease is inside. So if you move now in a very, very small way, like oscillating, the grease is gone away, and we have a steel-steel contact, and the bearing is gone. Therefore, for example, we just make a hybrid bearing, which we see here over there. So we bring, for the ball screws, we bring ceramic balls inside of the bearing. And this is the first bearing as well in this portfolio for the heavy cutting machines, for the heavy cutting materials, that we have the right ball screw support bearing with the ceramic balls to keep the machine alive, because otherwise we always face the problem in the lubrication. Coming out from that, we just have as well the perfect motor coming from Suhl, from our colleagues in Suhl. So they make very strong motors where we have, on the one hand, a high torque, and the opposite side we can go as well in a very high speed. So in the same motor, so there are special coils inside, special arrangement of the magnets. And then last but not least, we have the YRTS bearing, which we have now in a very, very higher chorus. So we call it PRL 15. So the run out is 50% of the standard. So this is something what we want to do for the customers, that they find the right products in combination. And I just want to show you that we don't think only in the bearing. We think in the bearing, in the drive, in the measuring system, in the linear axis. So we try to see the whole system to fit, that it fits to the machine. Here we have had as well the discussion, it's a little bit the same. So what I'm working at the moment, what is something new, what we want to point out. So at the moment, there are big requests. So I need a 1,000 size table blade, so 1,000 millimeter, and it should run 1,000 RPM. And this is really challenging. because at the moment, a lot of people are using ZKDF bearings. We love that because they are expensive, and we love to sell that. But on the opposite side, this is a ball bearing. So you have only a point contact. So the rigidity about tilting is only 30% versus if you compare to YRTS bearing. So what I'm doing at the moment is I try to make the right bearing in the YRTS version to fulfill the 1000 RPM for the 1000 millimeter of table plate, and to get here a stable bearing, temperature stable bearing, due to precision, and that everything runs very properly and very smooth. How did I do that? I make a patent for that. So here you see how it looks like. So the most important sensor is the sensor 2. This is an eddy current sensor, and we measure the movement from the outer ring and the inner ring, and we can then calculate the preload of the bearing. And it's very important, like I explained before, that the preload of the radial runway is always perfect matched to the application. The idea is to give you later on, as the machine tool builders, to give you a database that we can find out, that we can tell you, hey, if your application looks like that, so you increase the speed, please cool down the bearing in this way, that the preload is perfectly fitted to the application, and that we then can get this kind of high-speed bearing, and on the one hand, in combination with a very stiff bearing. So this is a target what we are working on the moment at Schaeffler. Last but not least, we have as well the product for the YRT-A bearing and the YRT-CGMA bearing. So what we see as well is to make the assembly easy, to make life easier. We have made a new bearing, and we have as well a patent on that. That we have a combination of gear, bearing, and measuring system, like I explained. Just to give you some ideas about that. So there were some people I know very well since more than 20 years, and he said, Martin, why does nobody make a bearing in combination with a gear? Why does nobody did that? I said, yeah, because we have bearing manufacturers and we have gear manufacturers. But nowadays we see, on the one hand, we have these very fast turning tables, but on the opposite side, we need as well standard-driven tables. So in the past, a lot of tables were driven by warm gear, but you know, a warm gear is always, you have to keep the run out. There are some benefits in the warm gear, but nowadays I think a spur gear is the right solution. Why is it the right solution? Because you can just easily get the backlash out by the control. You have 2 pinions to drive it. If you like, you take the 2 pinions with a belt, so you have a mechanical preload, or much easier, you make the preload together with a control. So you are over the time, you are backlash free. So the system keeps the accuracy from the beginning when you deliver the machine up to the end. The gear we make at the moment customized, so the requests, we are open for you if you come with some requests asking for that. The measuring system at the moment comes from EMO, yeah, and then we have the reading head, like I said already, which has a form contact and very, very easy to install on this part. I just give you a little bit how the design look like. So on the from your side, on the left side, you see we make a sleeve ring inside to center the gear, that this is aligned to the inner ring of the bearing. There is a little undercut that the reading head, what you see in the middle, that we can adjust the reading head. Here on the surface, on the inner ring, which is a little bit dark black, there is the scale, and then we have the reading head and the gap there to make the measuring here directly. Last but not least, you need to assemble it and you need to disassemble it. So therefore, there are 3 holes inside of the gear. So from this side is the table plate. You assemble it, you go through the table plate, through the gear, assemble the outer ring to the housing, and then There is a surface on the gear where you can take a lip sealing that you can separate the oil area from the grease area, that there is no contamination. At the end, you close the assembly hole, and that's it. It's quite easy to install. And I'm really proud about that. So I got the first project for this kind of bearing. We talk about 600 axes. So I'm really happy to show that we are here on the right way, and that we can fit to the needs of the market. They forced me to get only 25 minutes, half an hour to speak to you. Many thanks. I hope you liked the presentation. We are in Hall 6, booth I-46. So we are happy if you join us. If you have additional questions, I'm there. You can see the big guy. Just come here and ask me. So I try to answer all the questions. On all my other colleagues, we have a lot of colleagues from the application inside. So it's quite easy to ask and to get the news what we can do. So here we are.
Martin, thank you so much. What an awesome presentation. Very energetic, yeah?
Thanks.
I had no sound in the back, so
sorry.
sorry for that.
But so I make it private for you again if you like it.
So I may ask some questions that you already answered, but let me ask them anyway. So this is your chance now to ask questions here that are much more competent than mine will. But anyway, let's stick to the topic. One of the major topics we see here at the EMO is automation everywhere in every single point. And my question is, so it's growing so fast, how do your rotary table bearings support this trend? So
exactly, this is a new line. This is a YRTA bearing. So this is a very price-sensitive market, yeah. And like I pointed out, so we are able to reduce this old lady in the price, the YRTC bearing. So we cut off everything which is not needed, and therefore we can reduce approximately the costs 35%, and we are able to give this to the customer as well. So it's very price competitive. Honestly, the feedback of the bearing is too good. Yeah, so we got already customers telling me, Martin, you know what you did. I said, yes, I know, but it's always like you have to start and you have to make a catalog. Approximately, we are half time better than in the catalog that it was written, so the accuracy is very, very good. But from price-wise, it's very interesting, and we want to come to that market. And getting a little bit out of mind that Schaeffler is always expensive like hell. We are expensive, but we are as well. We can do everything, so we can do the low market, I would say the automation market, up to the high-end market, and I think this is one of our strengths.
What is really surprising to me is that in a product like bearing, there's still so much potential for innovation. Isn't that? I mean, this is so old, basically, yes. And it's crazy that we each year see new innovation in this field, right? How do you keep up the level of innovation?
Yeah, but you know, it's like that, you know, if you go to a customer and they come and say, hey, Martin, I have vibrations there. What can we do? And then sometimes you need a drink or you need alcohol or some legal drugs, I will say. And then you just sit there and you create something new. Yeah. And this is what, for me, makes my passion to stay, to make that. Because like you pointed out, yeah, this is old technology. So everybody knows it, everybody is familiar. But then some people come with requests. You said, oh, I never thought about that. Yeah. And then for me, it's like, I want to give them, we as Schaeffler, but me personal, I want to give them a solution. I think about, okay, how we can solve it. So honestly, I'm a little bit proud of that. If I can say that, we have already, my colleague and me, we make 12 patents since I'm at Schaeffler. I'm 6 years now at Schaeffler, 12 patents, so 2 patents per year in this area. So it's quite interesting field. And you see it with my passion, so it's always, I go to the customer, I try to find the best solution, and then, you can be proud when you see something like that. Yeah. And for example, in the past I was working for a big rotary table company, and I make a lot of rotary tables for the Airbus 380. And my girlfriend asked me, Martin, what are you doing the whole day? And I said, I cut metal. And she was like, what's about cutting metal? And I said, yeah, but when we fly the first time, I said, look, we make the machine here, we make the machine here, we make the machine here. So you have to think about, we have now the request for tools, 0.5 micron, for drilling tools, 0.5 micron. This is not even a hair. So, and these are tools that they need to machine. and then they come back and ask for a special YRT bearing which fulfill the needs of this tool. On the opposite side, we have parts with some tons in a high accuracy. So the range, the spread is this wide that you can imagine that you have to think sometimes out of the box to think, shit, what is the problem, what we have to solve here? And honestly, it's not the machine tool builder trying to explain me how my product should run. No, I need to know the need of the customer, and then I need to make this big company run, yeah, to make the right product, yeah, for the right thing. So this is my passion, you see.
Yeah.
And sorry, I have to stop probably.
I think at least not only for the passion, but also for the excellent speech and for the inspiring words. I'm kind of jealous. I mean, you found your job, man. So big applause, ladies and gentlemen. Martin Ecke von Schaeffler.
Thank you.
Martin, good luck for the booth. I'll let you go here. Thank you so much.